Cosmos Award, set up in memory of Carl Sagan. I was a great admirer of his television series, Cosmos, and so was very pleased when he agreed to write the foreword for my book, A Brief History of Time. I'm sure that foreword contributed to the success of the book. Sagan was a great advocate of space travel, and so am I. I will therefore address my remarks to this subject. Why should we go into space? What is the justification for spending all that effort and money on getting a few lumps of moon rock? Aren't there better causes here on Earth? In a way, the situation is like that in Europe before 1492. People might well have argued that it was a waste of money to send Columbus on a wild goose chase. Yet the discovery of the New World made a profound difference to the old. Without it, we wouldn't have had a Big Mac or KFC. Spreading out into space will have an even greater effect. It will completely change the future of the human race and maybe determine whether we have any future at all. It won't solve any of our immediate problems on planet Earth, but it will give us a new perspective on them and cause us to look outwards rather than inwards. Hopefully, it would unite us to face a common challenge. This would be a long-term strategy, and by long-term, I mean hundreds or even thousands of years. We could have a base on the moon within 30 years, reach Mars in 50 years, and explore the moons of the outer planets in 200 years. By reach, I mean with manned, or should I say, person space flight. We have already driven rovers on Mars and landed a probe on Titan, a moon of Saturn, but if one is considering the future of the human race, we have to go there ourselves. Going into space won't be cheap, but it would take only a small proportion of world resources. NASA's budget has remained roughly constant in real terms since the time of the Apollo landings, but it has decreased from 0.3% of US GDP in 1970 to 0.12% now. Even if we were to increase the international budget 20 times to make a serious effort to go into space, it would only be a small fraction of world GDP. There will be those who argue that it would be better to spend our money solving the problems of this planet, like climate change and pollution, rather than wasting it on a possibly fruitless search for a new planet. I'm not denying the importance of fighting climate change and global warming, but we can do that and still spare 0.25% of world GDP for space. Isn't our future worth 0.25%? We thought space was worth a big effort in the 60s. In 1962, President Kennedy permitted the US to landing a man on the moon by the end of the decade. This was achieved just in time by the Apollo 11 mission in 1969. The space race helped to create a fascination with science and led to great advances in technology, including the first large-scale integrated circuits, which are the basis of all modern computers. However, after the last moon landing in 1972, with no future plans for further manned space flight, public interest in space declined. This went along with the general public's swing against science in the West, because although it had brought great benefits, it had not solved the social problems that increasingly occupy public attention. A new manned space flight program would do a lot to restore public enthusiasm for space and for science generally. Robotic missions are much cheaper and may provide more scientific information, but they don't catch the public imagination in the same way. And they don't spread the human race into space, which I'm arguing should be our long-term strategy. A goal of a manned landing on Mars by 2030 would reignite the space program and give it a sense of purpose, in the same way that President Kennedy's moon target did in the 1960s. A new interest in space would also increase the public standing of science generally. The low esteem in which science and scientists are held is having serious consequences. We live in a society that is increasingly governed by science and technology, yet fewer and fewer young people want to go into science. A new and ambitious space program would excite the young and stimulate them to go into a wide range of sciences, not just astrophysics and space science. A high proportion of today's scientists say their interest in science was sparked by watching the moon landings. What will we find when we go into space? Is there alien life out there, or are we alone in the universe? We believe that life arose spontaneously on the Earth, so it must be possible for life to appear on other suitable planets, of which there seem to be a large number in the galaxy. But we don't know how life first appeared. The probability of something as complicated as a DNA molecule being formed by random collisions of atoms in a primeval ocean is incredibly small. However, there might have been some simpler macromolecule which then built up to DNA, or some other macromolecule capable of reproducing itself. Still, even if the probability of life appearing on a suitable planet is very small, since the universe is infinite, life would have appeared somewhere. If the probability is very low, the distance between two independent occurrences of life would be very large. However, there is a possibility known as panspermia, that life could spread from planet to planet, or from stellar system to stellar system, carried on meteors. We know that Earth has been hit by meteors that came from Mars, and others may have come from further afield. We have no evidence that any meteors carried life, but it remains a possibility. An important feature of life spread by panspermia is that it would have the same basis, which would be DNA, for life in the neighborhood of the Earth. On the other hand, an independent occurrence of life would be extremely unlikely to be DNA-based. So watch out if you meet an alien. You could be infected with a disease against which you have no resistance. One piece of observational evidence on the probability of life appearing is that we have fossils of algae from 3.5 billion years ago. The Earth was formed 4.6 billion years ago and was probably too hot for about the first half billion years. So life appeared on Earth within half a billion years of it being possible, which is short compared to the 10 billion year lifetime of an Earth-like planet.